Hello, today's video we are going to machine some front wheel spacers. This is a setup rim that we are checking the maximum width. With the racetruck you have a maximum width allowed, and we actually produce wheel spacers to go in between the disc and the front hub, and these are in the regulations obviously, but we make them out of aluminium just for weight and ease for machining. It starts life as the billet here. We'll get this mounted in the lathe in a bit, get it start to turn it down. We have around 10-20 mil we have to take off before we get to the nominal OD. Disc is a bit rusty as well because we're setting the front water jets up as well, so that's why they're a bit scabby. So yeah, we'll get this billet mounted in the lathe now and start turning it down, and yeah, hopefully in a couple of hours it'll start looking like a wheel spacer. So we've done the first 3 cuts, so we've got the OD, the sort of hub face OD, and then the surface face finished. We're just going to trial fit the hub on to make sure that it's bang on. It should be bang on because we've used the vernier to measure it, and it's within, well, I can't see the tolerance and neither can Tom, so it should be bang on. And then obviously all the swarf will collect up, go in the bin there, and then we'll send this for recycling. That doesn't even rattle. That's how perfect it is. So I'm quite happy with that. Absolutely can't even get my fingernail in. So I'm more than happy with that. Cut it off here, probably use bandsaw. Bandsaw. And then we'll mount it in the lathe on this face, because we know this face is 0. Turn it around, we'll do the other cut here, bore it down the middle, finish the 3 final faces off, and it should be good to go. You can see we've done the 3 faces, cutting it off with the saw now. Good thing with this saw, it's automatic, so we can just let it run. And it's got like a hydraulic speed, so it's pretty easy going. This is the biggest time saver, especially when we're making the subframe and we're cutting the solid material. Like this. So we literally just set it running, walk away, do another job, and huge time saver. So cut that one off. Cut the second one off, and then we have the 2 sort of pieces ready to do the final cuts on it, so hopefully it all fits this week, and we'll probably do that tomorrow. It's been cutting for I think 2.5–3 hours now. We go really slowly, not to put too much force on the blade because it's not a very big bandsaw. As you can see, it makes a lot of swarf. We'll also recycle that. Once it's cut off, we'll then mount it into the lathe. Got one done last night. So that's the front face, which is finished. The back one, that's saw finished, so we just need to turn that down and then put a return in it so it mounts onto the brake disc perfectly, drill all the holes, countersink them, and then that should be done. So yeah, but like you say, it's or like you see, it's the bandsaw. It doesn't cut all the way through, so we got to somewhere here, and then spun it around and did the final cut. So we got it to within 0.03 of a mil, which is good enough for us. I mean, our tolerances aren't as sort we don't need it to the micron, so from that side that should do us quite comfortably. We'll get the front turned down and then we'll start putting the recess in it to mount to the disc face. So the reason why we do it on the pillar drill and not on the miller is we don't have enough forward back movement on the bed, and it obviously takes a bit of time to program it up, but it's just as easy and quick to do it like this. Okay, it's not perfect, but we'll be within 0.1, 0.2 of a mil, so it'll be for the application it'll be okay. So once we've drilled them, we just need then to countersink all the holes so it flows, or so there's no like burrs in it or anything. So and then yeah, then it's done now. So yeah, we've got the 45 on it. I don't know if you can see that. So that was what I was saying, just to make it a bit nicer to work with, and just looks a bit nicer, and you're not going to cut yourself open or anything. And then we do have a finished one, or let's say finished with that. So that's all drilled. As you can see, it looks pretty good. Countersink it. Once it's countersunk, then it's finished, just to get rid of the burrs. It's amazing how much, like I said before, amazing how much swarf is created just from a little bit of aluminium. And like I say, it was only 2 mil, so it was only 2 mil thicker either side to stop the saw, or to consider the saw wonder. So we weren't going to end up with like a cavity of no material, and then obviously it was, I think, 10 mil wider either side, so machine that down, and then the centre out, and we machine the centre out is just to get rid of the weight. There's no other reason. Obviously it's not a lot of weight, but it all adds up. And then we did actually, or we do have, that's an old disc that we had from PE, and it was expired the life, so we cut the bell off, and then the disc rotor, and now that is a workshop template, and then that we just use on the saw just to see how much play there is, and there is absolute zero play in it. So it means that every time we mount the hub to the spacer to the disc, it'll be zero, and we won't have a wheel imbalance. So it's yeah, for a small workshop in Lancashire, we don't do a bad job. So we got the new one. This is the old one, which is was on for measuring. Comes off. You can see that there's a slight difference in the thickness of them, and the reason why we make the spacers on the sort of face of the disc and not on the actual hub itself is to spacer that, and then to make sure that the rim self-centers correctly. It'll take a lot of material and a lot of strain on the bolts, so we do actually just mount them straight onto the disc like that. The reason why we have these studs like this is it's easier on the back, but also so the disc can't rotate and knock the water jets on the back, because they're quite sensitive part, and if we damage them, it makes there's no point, or it makes no sense to actually damage them if you can prevent it. So everything seems to fit okay. Get all these bolts in, and then we do actually need to make the studs. We do use standard studs, but we have to cut them down because we use a special front wheel nut on the front axle. This is to stop when the trucks come together. Is when we found, or the FIA found, it was quite dangerous with the standard wheel nuts, because it'd be like a formula car. So as they came together, one wheel nut's going 100 mile an hour down, and the other one's going 100 mile an hour up. So if you can imagine that when they come, like when a front one from a truck comes to the back one, it fires them up like 2 meters up in the air, like the whole truck 2 meters up in the air. So we have a special domed wheel nut, which is a lot safer. It causes less damage, and some of the more professional drivers with the standard nuts on, they would actually come to the back of a sort of rival truck, and they would lean on the back wheel a little bit, and it would actually cut into the tyre or cut into the aluminium, and then they'd lose the pressure, and then it would be deemed as a racing incident, and then the tyre would deflate over either a few seconds or a few minutes, and then they have an advantage to overtake. So these front wheel nuts are now designed to have it more fair and for everybody, and obviously a lot safer. So and then we'll take them out, and obviously we made these spacers on the lathe with the digital readout, which is a lot more easier. The old spacers we made were on my old lathe, and the old lathe was quite old, and it wasn't very it was hard to do repeat work because we didn't have the DRO on it. So every measurement you can see there, I actually used the caliper gauge, and it took ages to make them. Whereas these, it was literally make one, write all your numbers down, or know how the DRO is set up, and then I produced the second one in a quarter of the time as of the first one, so that made life a lot easier. Fitted, everything looks good. Thanks for watching. Don't forget to give it a thumbs up. We'll try and do more technical videos, but obviously we have to keep a fine balance of showing you enough but not showing you everything. But as you can see over my shoulder, there'll be other race teams watching it, looking at the chassis, not looking at my ugly face. So yeah, but yeah, like I say, give it a thumbs up, and if you've got any questions, comment on it, and yeah, we'll keep them coming.